During 2017 and 2018, she was a postdoctoral fellow at the Autonomous National University of Mexico. Currently, she's a full-time professor with the engineering faculty of Universidad Panamericana and an honorary research associate in the Department of Computer Science at the University of Warwick. Her principal research interests include image and video processing, object detection, computer vision, video coding, watermarking, and artificial intelligence. Welcome, Karina. Thank you for being here with us.
Good morning to everyone. And as already told you, Professor Lourdes, today we are going to be giving this tutorial about OCR from fundamentals to real life applications. My name is Karina Perez. Yeah,
sorry to interrupt. For you, it doesn't appear because you are not the owner of the account, but in my case, I can tell you that the session is already being recorded. Okay.
Okay, thank you. Yeah, and then we have so many ways to improve our OCR performance. First of all, we may need to apply OSD to determine the text orientation and maybe to rectify this one. We have another assumptions like a particular script or writing system. So any assumption we can do about our particular problem, this is going to be an input of our OCR system to improve the accuracy. We also have many other OCR engines like Tesseract or cloud-based APIs, and maybe more accurate, or maybe we can obtain a better accuracy if we apply some computer vision on image processing previously to our OCR system. Other considerations that we may have is that how can we improve OCR accuracy? And we have to think about this one. How can we apply automatic check spelling to correct misspelled words? Our OCR system is going to be that. It's going to be doing that. And can we use regular expressions to determine patterns on OCR outputs, or it's just like the character recognitions? And also we have to think about, can we use previous knowledge to have about the nature of the data? So maybe we can assume that our text of interest is in certain part of our document. So this is some of the considerations that we may consider before starting with our OCR system. So maybe here's well, here I already include some Tesseract APIs that are already performed, but let's talk about Tesseract OCR. This is well, for many of us, it's a bit obscure library, but actually it is not. It is performing an LSTM neural network to perform the OCR character recognition. So please, let's consider this. Actually, we have no the freedom to modify Tesseract, but we can have some intuition about how it is working, since we already know that it is using an LSTM behind. So let's go to Google Colab, and please, if you have any question, don't be afraid, ask. So yeah, here we have the tutorial, and actually it is divided in 4 sections. First of all, we are going to have some of the installation of tools, libraries, dependencies, and some other stuff like this. Hands-on Tesseract, image processing and OCR using Tesseract, and detecting machine readable code on a passport. And finally, some drawing of bounding boxes. That's something very interesting. Well, the first step is about the installation of tools, libraries, dependencies, and importing libraries. And actually, on our own computer, it's gonna take quite long, maybe like 1 hour and a half, depending on your machines. But on Google Colab, with using the free account, this is take like 50 minutes. So we are not going to put attention on this one. So we are going to assume that we already have these libraries installed, and this is the short version of library installation. So you just have to follow these instructions, and then you can go further. But I am of the old school, so I really like building the libraries by my own. So make the long story short, you can copy these lines of codes, and you can use your Tesseract version. Actually, the one that is built in using these lines of code, it's Tesseract 4.0. So let's consider this one. Well, first of all, let's try about how to import images in OpenCV. I want to be assuming that you already are familiar with this image importing, but just to, I will share you the link later. Well, first assume that we have a connection to our Google Drive. So this file is inside of my Google Drive, and we are going to be reading the images from this storage. So we have here this is the name of my image, is business card 2, and actually this is the business card that I am trying to read using OCR. Then what we have is we are already let's start by this. Here we are like importing OCR and leave Tesseract, and then using this library, we are giving us the installation of PyTesseract, which is the Tesseract API for Python. So we are assuming that we already have this, and then we have the PyTesseract to image, dot image to string. This is the method to convert our image into text. We are also giving here the input and the language as an input. Here we are assuming this text is written in English. So this line is actually the only one line that we have that we may need to convert text to Tesseract. And maybe you may think, so what is the purpose of this tutorial? We just need one line. So I will show you the particular cases. So using just this line of code, you can convert this business card into text. But we have some problems here. What are the problems that you may find? Anyone can want to participate and tell me which are the problems that you may see in this text recognition? Okay, if not, yeah.
The email address is not fully, it's not completed.
Yeah, and also you have here some symbols, which actually are not part of the actual information of business cards. So this is what happened in one of the best cases when we use just this line of code, just like an out of the box system. So later I will show you how can we improve this accuracy. But then let's talk about how can we retrieve some certain information of that business card. So here we can use regular expressions. Of course, we have to import the regex library. And from here, we are just using some regular expressions algorithms to first find all integer digits in our text. And then we are just join all the integer digits that we found during this list number. So if we are just interested in retrieving just the numbers that we have during in our text recognized, so we can use regular expressions. Another maybe important thing that we may have is that how about blacklisting? And also we have whitelisting during our OCR performance. And what is a blacklist? This is a list of certain symbols and numbers that we do not want to appear in our text recognition. So here I am saying, I don't want any number and any of these symbols. And maybe I should include more symbols, but I just include these ones that are the ones that appear during our first approach of text recognitions. So I am skipping this symbol of Japanese yens. I am also skipping these symbols of cents and any other symbols. So here I am saying to Tesseract, please do not consider these symbols. And this is the opposite with the whitelist. We are giving which are the main characters that we are looking for. So here we have this blacklist. I give as a parameter, and here I am saying this C, it is activating this function. This is saying tested char blacklist, and this is the lack of blacklist symbols. So as you may see, our actually here we are going to work with several languages, but let's move to these installations. Making this long story short, I'm sorry, let's move to this one. Yeah, actually, you have to import this test data, which is part of Tesseract OCR, which is in this GitHub site. So you import it, and in this test data, you can find any language. Well, not any language, but just a list of 166 several languages. And here I put several of these languages and its corresponding code in Tesseract. But yeah, yes, we can use Tesseract in several languages, and of course we can make Tesseract part of our own list of preferred words. Yeah. So here, this is the result of our blacklisting. And as I already told you, we are skipping some of these symbols, but maybe we have to use another kind of techniques to recognize or to distinguish which is the this @ symbol, which do we want to maintain and which do we want to skip it. And yeah. Another interesting fundamental that we may know about OCR is that we are going to find all occurrences of a certain word. So here I have like a kind of a text. This is the text about animals, dogs, foxes, and so many other stuff. Another important thing that we have to consider is that Tesseract does not work with BGR images. So we have to convert it to RGB images. So this is, let's remind that when we are importing some images into Python, using OpenCV, we have the BGR structure, so we have to convert it into RGB. So this is why I am putting this line of code here. I am importing this image, and then I am using just the simple string that I already used, that is by Tesseract dot image to string. I am giving the image as an input, and here it is our text. This is quite an awesome, right? And why do you think that this Tesseract function works better with large text rather than with this small business card? Do we have any idea? Well, this is because Tesseract was trained using this kind of images, so with kind of a large text instead of being trained with this kind of images. So this is why. So this is working better using large text. So here we have our text, and then again we are going to use some, and also because of the fonts. Yeah, that's right. And yeah, so Here we have our target word. This target word is the word dog. And then I am using this another function method, which is image to data. So I am storing in data the number of occurrences that this word appear during the detected text. And then we are going to use this expression, which is not part of Tesseract. Actually, it's just like retrieving the target occurrences. And I am going to use, okay, if word is lower, then this is my target word. If this is true, then I'm going to use this function, which is enumerate. And I am read this word like is dog from this data. And then I will be evaluating word by word of the retrieving data, and every time it appears, so I will be storing this using our target occurrences. So let's move on. So once we already have the target occurrences, we may want to find which are the right coordinates of our target occurrences appear during our text. So I am giving which is the width, the height, the length, and the top, and I just will be evaluating this. So this means that from data, we retrieve two things, which is the word, and then where is the word. So we already have this information from data. And yeah, I will be defining all the surrounding boxes points using just, I will be defining the rectangle on OpenCV, yeah, right? So I am using which is the length plus the width and which is the top. So and this is kind of just stuff for drawing rectangles. Then I will be drawing those rectangles on the already detected points. And then I will, well, civil line just, it's for drawing lines, right? These lines are gonna be in color. So let's remind that this is BGR, so it's are in blue. And the thickness is 2. So let's see how it works. Here we have our text, and actually we are already detecting very well our words, our target words. So please tell me if you have any question about this piece of code. Does it make sense for you? Here it is another interesting thing that have OCR. So we have the correcting orientation. Here we have anything. Yeah. Yes, of course. I am putting here just the best cases. So first of all, I will give you some introduction to any of the function that we may have using Tesseract. But then I will put a case that it's not perfect. So we have to perform some image processing previous to Tesseract. Here we have another very beautiful image, which has no noise, where the layers are very clear and where the fonts are very very clear too. So here we have an image. This is called 90 degrees text 2, and also we have to convert it from GR to RGB. And here we have the image to USD. Some of you remember what OSD stands for?
Orientation segmentation mouse.
Yeah, that's right. So here we are going to detect if we have any particular orientation using this function, which is called OSD, which is part of Tesseract. So from here we are retrieving the information. Actually, we have several labels. One is rotate, another is characters. In this case, it's gonna be Latin. And we have another information similar to this. So I am interested just in information about rotate. And from here, I'm going to retrieve to look. This is going to be retrieving a list, a Python list. So I am looking for this word rotate during this list. And then we'll find, once we have the angle, so let's just print it. And here we have that the angle is 90 degrees, which is actually correct. So from this, we can say that OSD is working very well. And yeah, we can use this one if angle it's larger than 0. Of course, I am assuming here that we have 90 degrees. I will use rotate 90 clockwise, which is part of OpenCV, but we have another option, which is rotate 180 and rotate 270 or 90 counterclockwise. Yeah, and from here we have to make this this realignment again, and we have the text that where we can actually detect very well the characters from this. And also we are going to have another example. This example is about OCR translations. So from here, we are going to also assume that we have some text. This text is in Spanish, of course. And here we are going to say, okay, yes, Daddy.
Yeah, I had a question regarding the orientation of the text. What if you had an image with 2 strings of text, one which it has an horizontal orientation, and the other piece of text is vertical? What would you do in that case?
Yeah, actually, in that case, OSD it's gonna be working very, very bad. So what we have to say is, let's say that we have one text like this, and we have one text like this. Well, first of all, what we have to do is not put this image as a direct input of OSD. So let's say we have to have some assumption, and using image processing, we have to say, okay, we have to first of all segment this page, and giving this small piece of the page as an input, and then using this as another input. So here we are going to have 2 inputs, but OSD does not recognize it automatically. What we have to make it like segment the page first, and then giving this as an input of our OSD. So is it clear?
Yeah, but do you do that manually, or is there a that does that?
There are several things, and so let's remind that during this tutorial I will give you some passport detection, and actually this is a very real life application, and we are going to see there how can we make this segmentation. But yes, you have two ways of doing that. First of all, if you have, let's say, a bunch of documents, let's say 100 of documents, and all of your documents have this orientation, like in diagonal in the upper left part of your page, and the horizontal on the down right part of your page, you may have some assumption and then build a function to manually cut your page. But if not, you have to make some image processing techniques and try to automate this stuff. Yeah, but here first, yeah, thank you. During this first part of the tutorial, I'm just giving some insights of what you can do and what you cannot do during using Tesseract. Then I'm going to give you some intermediate level image processing inclusion of functions to this as an input of this OCR. And then I will give you a very practical application. So in there, you are going to face several real life problems that you may have in a document. Yeah, so another thing we can do is translation. And this is a piece of text, which also is an ideal case where we have this string. And well, we are assuming that we already know that we have this text in Spanish. This is the code for from Spanish. And then I will give you this code, this configuration, which is page segmentation mode 6. Later, I will give you how well the other different PSM modes that we have for Tesseract. But let's first here assume that we have this PCM mode. So the text as was recognized, it says reconocimiento óptico de caracteres, and this is gonna be the text in Spanish. So I will use, and this is very new, right? Usually we use text blob for text translation, but text blob it's no longer working. So this API it's not longer working. So we have to use this Google Trans that we are making a connection to the Google Translator. So any language that is available on Google Translator and it is available on our test data, so we can make that translation. So we are going to import translator from that Google Trans library. We are building an object about this translator, which is called translator2. And then I will use the method detect. So I will give the text as an input, and I will retrieve the language detected. And then I will give here the language detected, which is, okay, your text is in Spanish. And let's say, I will show you something. The code is different from the Google API and from test data. In test data, the code is SPA, and in Google Translate, it's AS. So this is quite different, but we have to make like, well, if we are interested in compare these two outputs, we have to make like a dictionary which is the code in test data and which is the code in Google Trans, just in case that we want to verify that it is actually the text that in the language that we are going to translate. This is the Google Translate languages that they have support and which is the code. So I put it here just for your records. And then we are going to translate the text, which is this one. So let's remember that we already recognize this text. So first of all, if we have to make an algorithm, it's read the image, using image to string to retrieve the actual string. And then we have to use the translate. So this is here, we want to translate into English, but of course we can use any of these other languages. And yeah, the text translator is optical character recognition. And actually, this is already an app. If you remember, you have your phones and then you can start your camera. You can put your camera looking at that certain text and you have the translation. Actually, someone is getting profit from these applications. So do you have any question about the translation? Let's go to our next application, which is using some image processing basic algorithms and OCR using Tesseract. So let's first of all talk about PSM. So I will give you here. Actually, we have 14 PCM modes. But before talking about these 14 PCM modes, let's talk about how to improve OCR performance. So one of the first and main things that we may do is be aware of what are PSM modes, which actually this is implementing some classical image processing techniques inside of Tesseract. So this is very useful for us because it implements instead of us. But also, well, one of the advantages is that we doesn't not really care about what it's doing. But one of the downsides is that we have no controls over which techniques have been applied and which techniques are not. So PSM modes use classical image processing techniques as a pre-processing stage. We have also to practicing a lot to get the feeling about which problems maybe we are going to maybe facing and how can we improve this or solve these problems. So we also have to be aware that sometimes OCR does not provide any results, and actually this is something that happens, that even Tesseract is using neural networks behind and it is very robust to several texts. actually, sometimes we does not get any result. And also, maybe we can return some text that does not have any sense. So we have to be aware of that two things. And Tesseract expects a page full of text. Actually, this Tesseract was trained with that information. So when we are training our OCR in single line or of text, maybe we have we can retrieve an empty string or a text full of unknown symbols. So please let's be aware of this. And so let's talk about PSM modes, which is page segmentation modes. We have 14 from the code 0 to code 13. And then what can do with PSM modes? We can detect the text orientation, segmenting some text into columns, working on a single piece of text, word or character, and finding sparse text in a document. Sorry, this text is not part of here. Which are the modes? Actually, we have the mode 0, which is working with orientation and script. So this PS mode doesn't retrieve any text recognition. Actually, which is retrieving is if we have any particular orientation, and which is the script. The script means like we have kanjis, or if we have any Arabic letters, or if we have Latin text or something like this. When we use the PS mode, another important thing is that we cannot mix modes. We have to choose one or other, but not two PS modes or more. Also, when we are using the PS mode 1, we have automatic space segmentation, and this is not recommended because actually this part is not implemented yet in the current Tesseract code. And then if we use code 2, actually this is not recommended too, because actually this is an empty function during the current Tesseract mode. So let's remember that Google is developing Tesseract, but it is not getting profit from that, so they are not giving maintenance very often. Maintenance, sorry. And then we have, when we are using the PSM mode 3, actually this is the default mode. So every time we are using the method image to script, we are just using this PSM mode, which is for fully automatic page segmentation, but no OSD implemented. And then when we are using the code 4, we are assuming a single column of text of variable sizes. So maybe this is gonna be a better option for our business card example. And then when we are using 5, we are thinking of a single uniform block of vertical alignment text. So this means that we have, let's say, 5-word longer line, and every line have this fixed size. When we use the code 6, we are assuming a single uniform block of text. And when we use the code 7, we are assuming treat the image as a single line of text. And this is working very well with car plates. Actually, these car plates, it's not very good example using any of the other codes. And when we are using the PSM mode 8, actually we are using something very similar with which we are using with MNIST, just that MNIST is working with number detection, and this PSM mode 8 with Tesseract, it's detecting a single character, which could be a symbol or a letter or also a number. Okay. We also have any other PSM modes, and the mode number 9 is treating the image as a single word in a circle. Actually, I tried this one with several samples, but this is not recommended because it's not working very well. Actually, this is not doing anything very particular. Number 10, treat the image as a single character. Number 11, it's working very well. This it's for sparse text. So this means that if we have some page with some text here and some other here and some other here and some other here. And then we have something like this, like a normal letter. We have several alignment of the text, so maybe we can treat this like sparse text. So this is very good for letter translation and also for text in a letter detection and also for invoice detection. So maybe we before going to several applications, we have to make sense of which these PSM modes mean for this OCR detection. Also, we have number 12. Actually, this is not implemented completely, so maybe we can skip this also. And when we use the PSM mode 13, it's actually does not consider OSD or any special text alignment. So maybe when any of the others doesn't work, you can try using this PSM mode 13, which actually is bypassing all the previous OSD's implementation on Tesseract. So let's go to Google Colab. So once we already have an idea of what PCM mode means, actually I am giving as an input this receipt. And if I use just image to string, which is the basic line of code of Tesseract, actually my image is already an RGB. So this is what I get. Okay, so the text is quite a very well recognized, but we have one problem. So let's say we have here some text, we have here some numbers, and we have here some another numbers. And actually we are retrieving like, okay, these are the numbers, these are the text, and later we have the actual price of each product. So this is not bad, but maybe we can do better. So let's remind what our PSM mode 4 does. And so, is it not amazing? So we are actually retrieving the text as it appears in our receipt. So this is very good application of Tesseract. And actually we are not even giving any previous image processing technique. We are just using or making a correct sense of what the PCM modes or the built-in function that Tesseract already have. So what about a receipt like this? This is also a receipt, and let's make the assumption that the text is very clear, that the text does not have any part occluded and something like that. So we have this receipt and we are using PSM mode 5, and we does not even have to make any OSD previously. Actually, we can retrieve the text just like if it were a vertical alignment. So, do you have any question until here? So, let's continue. Here I have another piece of text, and actually, this piece of text is not in the ideal case that it is the previous one that when were recognizing this text. Actually, this text is the letters are very, very dark on a white background, and we have not any occlusion, we have not any noise or something like that. So this text is quite different. This actually may be any like the scan of any of our documents, right? This is very, very a real image. And actually we are just using the same code, which is image to string image, and we are just giving the configuration that we have the PSM mode 6, and actually we are retrieving very perfectly our text. So even though this image is not as perfect as the previous one, using giving a correct sense of what PCM modes are and how can we help be help about this. Actually, we are having this kind of text, which is very, very perfect for our applications. So here we have this car plate, and we are trying to use the same code with the default PCM mode, which is 3. And also, since it's the default, we don't have to put it explicitly here. And well, for me, this text is very clear. We does not have any particularity which may downgrade the performance of our Tesseract algorithm. But actually, we are not retrieving anything. And when we are using PSM mode 7, which actually is for one single line, we are retrieving the text like perfect. So this is because sometimes when you are using your Tesseract, you may say, okay, my Tesseract is not working, or maybe I am doing something wrong, and so let's move to the easiest way. So let's buy some application which are already implemented on internet, or maybe we have to buy some of the implementation of any cloud API. But actually, we can make it by our own, by be aware of the PSM modes. Here we have another let's say like car plate that are actually a photo, and actually an old photo. And if we are using the regular image to string line, and also if we are using the PSM mode, actually neither with image to string or neither with the configuration of PSM mode, we are not retrieving anything. So what do you think that we may do in these cases? So our first attempt is, let's use the built-in image to string function. If we say that this is not working, we can recur to PSM modes. And if neither of these two ways are working, then we can recur to image processing techniques. So, and actually here I am implementing several image processing techniques. So noise removal by median blur, and also thresholding by using Otsu algorithm. These are very well known in image processing field, and also some dilation, and also erosion, also opening, which is opening is an erosion followed by dilation, also edge detection, match template. These are very classical image processing techniques, so I am implementing several. And I decided to just try 4 of them. I used just the regular grayscale, the thresholding, the opening, and then Canny. And what happened? Well, here I am drawing these 4 approaches. The first one is grayscale, then the image threshold, opening, and Canny. And I am using just the default values, and maybe we summon it. In which do you think that Tesseract will work better, and why?
In the thresholded image.
Yeah, that's right. Actually, the threshold image, actually we have the white surface and black letters as a foreground. And yeah, actually I am using just the regular image to string function with several with the number 7 configuration of PSM mode. And yeah, it seems like to be some kind of magic procedure. We are retrieving actually using the grayscale. Well, the threshold, it seems, well, for us, it seems that will be working right, but actually it is not very right. And opening. These 2 are the ones that are working better. And actually in this particular case, Canny it's not working at all. But it's just in this case. Maybe in other cases it will work differently, but we have to try on our particular application. So using these very, very traditional and common techniques, we can improve our Tesseract modes. Okay. From here, do you have any question? No? So let's move to our example of a real life.
Sorry, I have a question regarding the filters or algorithms applied during the pre-processing state. So how do you go about this? Do you just do trial and error to like get I guess or one of the best approaches to pre-processing an image, or is there usually a suggested pipeline?
Yeah, actually, yes, there is a suggested pipeline, of course, but it depends of your application. Actually, if we want to make like an algorithm for like be universal, working very well for every OCR detection, actually this isn't, well, actually the image processing doesn't work like that. So the suggestion is first try with the built-in OCR in Tesseract, then let's try with PSM modes, and then with this image processing pipeline, let's try first with a grayscale. Then it depends of your of the results you are getting with the dilation. Maybe if your letters are already like this one, maybe you don't have to do any dilation or erosion. But maybe if your text has some discontinuities, of course you may have to do any dilation. So we doesn't have any, like, for every application you are going to use this step and then this and then this. So you have to, like, it's like a kind of an art, like all the image processing algorithms. You have to try several which work for them almost all of your examples of your particular application.
So trial and error, right?
Yeah. Yeah. Yes. Yeah. So here in this real life application, we are going to detect the machine readable code on a passport. So here I find some Mexican passport of Mr. Bean. So actually this is a fake passport, of course. But let's analyze this information. Well, I assume that most of passports have the same information. So we have, first of all, two pages. And in one you have some like say text about your, I don't know how to say, like your own country, or maybe any symbol of your related to your country. And then in the other page is information about our subject of interest. So here we have some words in the language of the country that this passport was issued. And then we have some information related to the person. And this information, it's actually, you can see that this information, since this is a Mexican passport, the information is in Spanish. But the information that every airport reads, actually, it's the machine readable code. So this information, it's the one that every single airport or immigration authorities read about us. Here you are here the passport provides the information about the subject. So since we already know where is the information of interest which is globally accepted, we are going to be skipping all this. So for our particular problem, since we want to detect the machine readable text, code, we are focusing on this part. So this is a first assumption that we may have. Okay, sorry, that we may do. Yeah. So first of all, I will give in importing the sort contours. This is just for, like the number says, for detect contours and then sorting because of due to the size of that contour. Then I am using the BGR to gray, just to convert to grayscale. Then I am build some structural elements for template matching. So I am using this rectangular kernel and also the square kernel. So this is just the definition of our two structural elements. If you are not familiar with this, so this is the elements that we may need for erosion and dilation in this application. And then we are like implementing a Gaussian filter, which is of size 3 by 3. And also we are using another, this is a black hat, which is very similar to erosion and dilation. And this particular algorithm uses the structural element too. So let's first say, okay, here I am showing the result of black hat algorithm. And if we compare our original passport, which is this one, to the result of black hat, what do you find? Which information is gonna be removed and which information is highlighted? So it seems that at this point, it's more or less the same. So we have also the same kind of noise. Only the one thing that we are skipping is all these watermarks and information about the background. So all this information, all this, and the texture of the paper, it's the one that we are skipping with this algorithm. But actually this is because of the Gaussian blur, not because of the white hat algorithm. So this is the result of our application. Then if we move to Sobel, actually Sobel is a filter to detect the first derivative of any image. So it retrieves the edges. And here we are just finding the edges in the x-axis. So we are not interested in retrieve this information. Actually, we are interested in retrieve these edges, the ones that are in like this, in horizontal position. And then the input of this Sobel filter, it's gonna be the black hat image. And then I will be using the contrast stretching technique, which is the one that it's very frequently used for putting all the values that are below to 0. So move to 0, and then the values that are above from 225 to move to 225. This is just to stretch the contrast, like the name says. So I am just using this contrast stretching technique, and also I am using some normalization, and then I am converting this one to 225 scale, and then I will show you the result. And I don't know, but for me, these results at the first sight, it says like, I don't know, maybe this is not very good. This is not very accurate. But so let's move to our algorithm. So let's remind, what do we want to do? What we want to do is to segment this part of the passport, right? So of course we want to recognize the text that is in this part, but first, but then before to detect the text, we have to detect the region of interest. So let's be aware of that. So reminding to this purpose that it is segment this part of the passport, do you think that this detection, this edge detection, it's right or it is not? Well, let's continue. Then, if I apply a dilation technique to this edge that we already detect, actually, so let's remember that dilation, what does, it's like drawing the edges in a coarser mode. So the edges, if we have with one single line, which is very, very light, then this very light line, it will be converted to a very coarse line. So when we use dilation for this, I'm sorry, here I am using, dilation for this. I am using, closest dilation and then narration. So I am retrieving like something like this. And actually we are refocusing on this page, which is where is the information. And from this, we can say that actually the text where it is our particular information, it's already like, how to say, like highlighted, no? So from here we can say, okay, I am interested in this particular area. So I am focusing on recognizing the area of interest rather than the text. So using this morphological operation and then thresholding to get the white, well, the mask, which is white information over a black background. So then I will be using also another close morphological operation. And then I will going to erosion. And then from this information, I am using this one. So do you think that it's gonna be easier to detect the text once we already know where is the region of interest, or it is better to detect since from our first image that it's like it is? So where do you think that it's gonna be easier to detect this? Actually, it is in this kind of images, but of course we have to make the page segmentation that we know, that we already know that we may want, which is recognizing this surface. So let's move to do that. And remember, you have to be considering some assumptions. So the code that I'm going to put here, it's to make possible this assumption that we already know. So first of all, I am saying, okay, I want to find contours over this mask image. So we are already forgetting everything about the original passport. So this is no longer available for our purpose. We are going to consider just this binary image, which is a mask. We just have pixels on 0 and another's on 1. And the information of interest, we already know that it's in white pixels. So we are going to find contours. So what we are expecting to get from this is actually this one, which is the contour of our text, and also this one, which is the contour of another of the other parts of the passports, this one and this one. And this is kind of the feeling that you may develop when you practice a lot with image processing. And then, so the purpose of this is sorting the contours. And these contours, it's gonna be based on the perimeter of every structure. So maybe we can say that this structure, it's gonna have a larger surface in general than the software of interest. Okay, so we have to sort the contours in terms of the perimeter, and then we are going to initialize a VBox variable, which is going to contain the bounding boxes. A bounding box, it's the box that is surrounding the region of interest. And then we are going to use the code, well, the function bounding rect to get which is the coordinates of every contour that it's been detected. So when with this we may retrieve the x and y coordinate from where the bounding box starts, and then the width and the height of that bounding box. And then we are going to be retrieving the percentage width, the percentage height in terms of our surface of study. And then we are going to will work with this percentage, and I established this by trial and error, which if it's larger than the 80% and also it's above of this 4% of the image, maybe this is a border of interest. So with this information, what I want to skip, it's just these small pieces. And then I will establish these parameters to find just the surface or the contour that it's in the above part of the passport. Then I will just keep this information. And then when I detect this bounding box of interest, I will use the image to string from Tesseract. I will replace the spaces, and then this is the thing that I am obtaining at the end of this algorithm. So tell me if this algorithm makes sense to you. So let's say that you have to make a lot of assumptions and a trial and error to find your best pipeline for this particular application. And finally, I am going to show you some interesting lines of codes just to detect or to draw the bounding boxes, but actually this is just like image processing and some other stuff. Like we are just using the image to data to get the number of words that are being detected using OCR. And then once we already know how many words do we have, we are determining which are which are the coordinates of that particular word. And then we are going to drawing a rectangle over every single word, and then we can like draw a bounding box over every single word detected, and then the transcription of the text recognized. And well, that is the end of this tutorial. I hope this is gonna be interesting for you. So please, if you have any question, so let me know.
I do have a question regarding the OCR tool used here. So why not other tools such as, I believe ECOCR is also kind of well known, right?
Yeah. Yeah, actually, we have several implementation of OCRs. Yes, that's right. And it depends on you. Actually, the best tool for you, it's the one that you are already more familiar with to work with. Actually, Tesseract works very well. ECOCR also works very well. OCRs from Google, Amazon, or Microsoft also works very well. So you actually have to be familiar with one and practicing a lot, which are the particularities of every implementation.
Karina,
may I ask what's your
sorry
go-to?
guys, I will interrupt you a little bit. Just to tell you that I will close the Bricket rooms in about 11:25 because we have the round table just after this. Okay.
Okay, thank you.
I will start the recording just to be sure to